Good day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Moses Maudu. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Today we are going to look at the topic that is done in paper 1, which is in algebra section, and the topic there is complex numbers. This topic in complex numbers, the complex number topic, has only 15 marks in paper 1. And this is the topic that we are busy with at school level now. By the end of this lesson, you must be able to. So these are bullets that we need to understand, and we need to know how to do this, so as now we can achieve the 15 marks that are in that question. Define a complex number. You must know what a complex number is. We need to work with complex numbers, including the following. We need to understand the I squared equals to -1, which we have done in grade 10. We need to also perform the operations with complex numbers, which is the addition. We need to know how to add complex numbers. We need to know how to subtract complex numbers. Also to multiply and divide complex numbers. We also need to understand what is a conjugate of a complex number. We also need to represent the complex numbers in Argand diagram, because these are some of the questions that can be asked in an exam. Determine the resultant. Determine the modulus, which we'll talk about in our other slides. We need to also understand what is an argument of a complex number. We also need to express a complex number in a trigonometric or polar form. So at the end of the lesson, you must be able to understand all these terminologies that I'm talking about. You know, the Argand diagram, what type of a diagram is that? The modulus, what is a modulus? The argument, we need to understand that. What do we mean when we talk about polar form or trigonometric form? The last part that we need to understand is how to solve complex equations with two variables. Obviously, if there are two variables, then we know that we need to do the simultaneous method. Let's talk to the definition of a complex number. Now, we have a number system that you have also done in grade 10. I think it's the first topic that you do in grade 10. We need to understand how the number system works before we understand the complex numbers. In a number system, we have a very small set of numbers which are called natural numbers. In the set of whole numbers, we know the natural numbers, those are counting numbers. You know, your 1, 2, 3, 4, those are counting numbers. We call them natural numbers. In a set of whole numbers, you can see the set of whole numbers include also the natural numbers. Obviously, the only number that we need to put there is 0. So 0 is a whole number. So it's 0, 1, 2, 3. So those are your whole numbers. So with the natural numbers are counting numbers, it's 1, 2, 3. So the only thing that we include to make a set of whole numbers is the 0. The integers, we still have the 1, 2, 3. So in other words, these numbers are still there. These whole numbers are still there. But what we add here, we just add a negative values here. So we add negative values. So with the integer, so you can see this natural numbers, the subset of whole numbers, and whole numbers and natural numbers are subset of integers. Now all those ones, you can see now again the whole circle here, we have rational numbers. In other words, what are rational numbers? Are all numbers that can be written in the form A over B, but where B it's not it's not equals to 0, okay? And A and B are the element of real numbers. So these are your rational numbers. Now, The set of irrational numbers is outside the set of all these numbers. So you can see irrational numbers are not part of rational. We can't say a number is irrational and rational at the same time. So it's irrational, it's outside the rational numbers, but everything else there, it's inside here, and these numbers are called the real numbers. So real numbers can be written like this. So it's a plus OI. Now that I there, we're going to talk about it just now. So it's a plus OI, and this is the set of real numbers. So then we have what we call imaginary numbers. So in the imaginary numbers, this is how we write an imaginary number. So where b it's not equals to 0. Because if b is equals to 0, then that does not become an imaginary number. Okay, so if I'm going to talk about a complex number, I talk of a number which has got a real part and also it's got an imaginary part. Right. So the real part is the real number. The imaginary part here, it is that number that we're talking about here. Okay, so when a is equals to 0, then we've got a pure imaginary number, which is bi. So bi is our imaginary part, and the a there, it will be our real part. So if I've got a real number and also an imaginary number, then the two form what we call complex numbers. Hope we all understand what is a complex number. So a complex number is nothing else but the real part plus the imaginary part, and that constitutes a complex number. So just the definition of what I was saying now, just the summary of what I was saying. The complex number is created when a real number is paired with the imaginary number, where a is the real part and b is the imaginary part. That is what I was explaining. So how do we write down, how do we represent a complex number? So we write a z, it's equals to this part here plus that part there. That is a complex number. So a complex number, if for instance I've got a z, it's equals to 5 plus 3i. That represent a complex number. Why do we say it's a complex number? Because the 5 is a real number and the 3 there is an imaginary part. So if I've got these two added together, then that number that I get there will be a complex number. So that number is complex because it includes the real part and the imaginary part. So if I've got something like this and says z equals to 7 or z equals to 9, obviously that must also be a complex number. Why? It is because if I add 0i, then in this case I'll have a complex number. So that number also will be a complex number, but the real part there is 9 and the imaginary part there is 0i. A quick activity on this one. We have got that complex number that is given there, and we need to identify which one is the real part and which one is an imaginary part, and we put them there. Nice activity in there. So which one in this first one? We have got 4 plus 3i. So I must know which one is the real part, which one is the imaginary part. So I'll have, which part will be the real part? The real number will be 4. And which part will be the imaginary part? The imaginary part will be a positive 3i. So that is an imaginary part. So we have a 4 which is positive and the 3i which is also positive. In the second one, we need to check whether the one that we see with an I becomes the imaginary part, but we take also its sign, so it's going to be negative 4 over 5. I is the imaginary part, and the real part will be 1 over 3. So that 1 over 3 there will be the real part, and the imaginary part will be negative 4 over 5. So we also take its sign. The third one, bit tricky there, but you must know your fractions. I mean, minus 2 minus 5i over 3. So if, for instance, I want to take an example here, just example that is not related to that. So the 2 over 3 plus 3 over 5, or 3 over 3, or let me say 5 over 3, right? If I work this sum out, the LCM is 3, and then the 2 there, 3 into 3 goes 1 times 2, it's 2, and that will be plus 5. So can you see now, the answer to this will be the same as this one. So if I want to break it, I want to take it back there, what should I do? I must then say 2 over 3 as it is, and then 5 over 3. So the plus sign will come here. Then we'll have 5 over 3. So I'm back there. So the same principle will also apply here. So in other words, in this case, I'm going to have negative 2 over 3 minus 5i over 3. So this and that will be the same. So then I can be able to write down which one is the real part, which one is the imaginary part. So the real part will be negative 2 over 3, and the imaginary part will be negative 5 over 3i. Write it like that. Okay, right. Now, the next one, 6i. I can see now you're a bit confused now that 6i, how can I make 6i? There's no real part here. Don't split the 6 and the I and say now the 6 becomes the real part and the imaginary part will be I. No, we can't do that. So which means this is the imaginary part. But I know the law of 0. If I add this number to 0, I still get that number. So which means that our real part will be equals to 0. Right. Now same applies to this one, where we have minus 7, it's added to 0i, because 0 times I is 0, minus 7 plus 0 gives us a minus 7. So which means our then real part is going to be negative 7, and our imaginary part will be 0. Right. So you must then understand what a complex number is. So this is very important that you can see. When you see a number with a z is equals to, then you know it's a complex number where the 0 will be, if we don't have one part, then the other part will be 0. If we have the other part, then the other part will be equals to 0. Right. Now, back to grade 10. So in grade 10, you did understand that I is equals to the square root of negative 1, or I squared will be equals to negative 1. Very, very, very important that we understand also that because when you do the activities, you see that wherever we have I squared, we must then change that I squared to negative 1. Now, let's simplify without using a calculator, obviously, without using a calculator. Now, I cubed, because I just know that I squared, it's negative 1. Remember this one here, that property comes from there. Because if I take the square root of that, and then I take the square root of that, then I get the square root of negative 1, it's equals to I. Please. So we're going to use, the one that we're going to use is this one for now. Now, if I say I cubed, how do I write down I cubed now? Using I squared. So I'll get I squared multiplied by I to the power 1. I know if the bases are the same, then I add the exponents. So the base is I, the exponents is 2 and a 1, 2 plus 1 is 3. But what do I know about I squared? I know that I squared equals to negative 1. So I can replace my I squared by negative 1, and then I've got an I here, right, to the power 1. So my answer there is going to be negative I. So that's what I get for I cubed. Right. So now let's change that one again to that. Let's change this one, should be I to the power of 4, and that one should be I to the power of 5. Right. 4. Right. So if I have I to the power of 4, how am I going to do that? Same thing. So I'm going to have I squared multiply by I squared, and I think I'll get a 4 here. 2 plus 2 is 4. So which means I'm going now to say, what is I squared? It's negative 1. What is another I squared? It's negative 1. So negative 1 times negative 1 will give me a positive 1. So the answer there will be positive 1. So obviously, everything that I do, I'm going to first start by doing your I to the power of 2. So even this one, then I'll get I squared, right. Then from there, I can then have another I squared, and I'm going to have an I, because 2 plus 2 plus 1 will give me 5. So therefore, that will be negative 1 times negative 1 times I, because the I can leave it like that, okay? So please don't change the I to 1, square root of negative 1. Just leave it as I there. So therefore, we're going to have negative 1 is 1. 1 times I is going to be I. So even if I take anything, I take I to the power of 30, for instance. In this case, what will I have? I'll have I squared. For me to get, I don't have to write I squared times I squared times I squared 15 times, because I know it will be 15 times. So I just divide that 30 by 2, so I'll get a 15. Then, but I know. So I squared is negative 1 to the power of 15. I know if I take minus 1 and multiply it 15 times, remember, I minus 1 to the power of 15 means multiply I to the power, multiply I 15 times, right? I multiply minus 1 15 times, sorry. So now I know if this is an odd number, what will happen? The value will remain odd. So it will, the sign will be a negative. So if I multiply minus 1 16 times, then it will be positive. The negative turns to positive. So it means in this case, I have minus 1 multiplying itself 15 times, and 15 is odd, but 1 times 1 times 1 times 1 times 1 times 1 will give me 1. So in other words, this answer that I'm going to get there will be negative 1. Right. If I had I to the power of 20, I'll still do the same. So I to the power of 20 will then give me 1. Okay, right. Then you have to also practice this. Let's look at negative square roots. Simplify the following without using a calculator. So in other words, even if you try using a calculator, you'll get stuck. So there's no way that you're going to get this if you use a calculator, because if you press it on the calculator and say, immediately when you say square root of negative 16, then it gives you an error on the calculator, which means there's something wrong that you have done. So in other words, when we're doing complex numbers, we can be able to do that. But because we know that if I'm talking about square root of negative 1, I know it's going to be I, remember. So the square root of negative 1 is going to be I. Right, so which means if I want to do this, then I have to say that square root of 16 multiply by square root of -1. If I break this down, I'm going to show it here. If I break this down, if I say 16 multiplied by -1, this is the same as square root of 16 times the square root of -1. That's how I've broken them down. In this case here, then I'm going to get, oh, by the way, we have that. Then we're multiplying it with, if I take square root of 7, I can also multiply it by the square root of -1. So in this case, what am I having? I'm now having 16 multiplied by, the square root of 16 is 4. The square root of -1 is I. On that side, I'm having the square root of 7, which I'll leave it as square root of 7, and the one will be I. So now, let me do it there. So I'm going to have 4i multiplied by square root of 7i. So the I and the I will give me an I squared. The 4 and the square root of 7, I can write it as 4 root 7. But what do I know about I squared? Then I'll have it as 4 square root of 7 multiply this one by -1. So that answer will be 4 -4 root 7. So that's how I can get it. You'll never be able to get it without using a calculator. If you use a calculator. If you use a calculator, you will not get it. You're going to get error throughout. Okay. Another way of doing that could be that you multiplied, because we are multiplying. Remember when we're multiplying, if I've got the square root of A multiplied by the square root of B, I can write this as square root of A times B. So in this case, I can do the same and say square root of -16 times -7. Then I can get the answer there, and with the answer that I'm going to get there, I can be able to work out the answer to this one. Right, but now remember, I must first do my i's, né? So I can then do the I there, and I can also do the I there, and then I can get to the answer. Okay. Right, I'm not going to complete that. So in this case here, the negative is outside, there's another negative inside. So what do we do here? So what we're going to do there is we're going to first multiply this positive 16 over 9 multiply by the square root of -1. Right, so this should be in brackets, right? So I'm going to get negative, open bracket, square root of 16 is 4, square root of 9 is 3, but I'm multiplying this one by that, so I'm going to get an I, right? So the answer that I'm going to get here will be negative, because I've got a negative outside the square root, 4 over 3 I, and that is the answer that I'm going to get there. Okay. Other way of doing it, I can split the 16 and the 4, and then from there I can then multiply that one by a negative, which is outside. Okay. Right. Now, the quadratic equations with complex roots. Please do not practice, if you're practicing your algebra, don't practice with a maths person, because the person who's doing maths is going to say, but if we take the 25 this side and square root on both sides, we don't have the square root of 25, of -25. But with us, we use complex numbers. So this type of questions, you might get them in question 1 at the end of the year. So you'll need to practice them. Or anytime in your assessments, you can still get these questions. Please note this, that in this instance, in maths we say there's no number that I can square and add it to 25 and still get a 0. But in complex numbers we are able to do it. So how do you do it in complex numbers? So we're going to say x squared equals to the square root of negative 25. Then I know that square root of 25, square root of negative 25 is the same as the square root of 25 multiplied by the square root of negative 1. So the square root of 25 now, it's 5. The square root of negative 1, it's I. But remember, in this I can put plus or minus, then I can have a plus or minus. So if I square that, so you can go and check it if it's correct. So if I want to quickly check, if I take square root of, if I take 5i and square it, so I'll get 5i, I square it, and I add 25, and that must give me 0. So which means that this answer there will be 25i squared plus 25, it's 0. Then I know that 25i squared, the I squared is negative 1. So negative times 25 will give me a negative 25 plus 25, and the answer that I'm going to get there is 0, which is the same as the right hand side. So I can be able to check it. If I take negative 5, it will be negative 5 squared, negative 5i squared, and I'll get a 25i squared, which will also come to this step here. Then I can just be able to do that. So we can be able to do that. So with the second one, same principle. I then say x squared plus that. So I can see here, first I need to apply the quadratic method because I cannot factorize it. So I'll get x equals to, we know that formula, minus b plus minus the square root of b squared minus 4ac. I'm just going to substitute here. So I'm going to have minus 4 plus minus the square root of 4 squared minus 4 multiplied by 1 multiplied by 5 all over 2 times 1. Then I'll get minus 4. I'm just going to add everything in there. So it's 16 squared. Sorry, 4 squared is 16. Minus 4 times 5 is 20. So I'm saying 16 minus 20, which gives me a negative number, negative 4 all over 2. Already I've got a negative 4 inside the square root. With the maths people, they'll say no answer or no solution, but we carry on. Remember this question, when they ask it in the exam, they'll say solve for x, then from there your answer should be imaginary. Okay, so you need to use the complex numbers there. Now in this case, we can split this and say it's minus 4 over 2 plus or minus the square root of 4 times negative 1. Okay, I can just put them in one that thing, divide by 2. So I can still write it like this. So there will be negative 2 plus minus, right? So there I'll have a 2i all over 2. Because the minus 1 gives us an I. So it will be minus I. So remember it's inside the square root. I can split those two. So my answer there will be minus 2 plus or minus I. Because then I'll have divided this by 2, and then the answer there will be equals to 2 minus 2 plus I. Because 2 into 4 goes 2 times. Remember here it's 2 into 1. Oh, sorry, that should be 4. Yeah? So it's b squared, so let's write it down, minus b plus minus the square root of b squared minus 4ac all over 2. Okay, right. Now, let's carry on. Right, the word conjugate. So this is where we change the sign of the imaginary. Once we change the sign of the imaginary, then the value that we get, or the equation that we get there, will be a conjugate. So a conjugate is when we change the sign of the imaginary part. So if the sign of the imaginary part of the complex number is changed, then the new number is now called a conjugate of the first number. Which means, if I've got z equals to a plus bi, then I change this sign of the imaginary. Then it becomes a negative if it's a plus sign. Then I write this in this order. So I now write it z with a bar on top. So that is called a conjugate. So in the sketch here, we have illustrated that the part, this one here, is the y-axis. But in complex numbers, we no longer call it the y-axis, we call it the imaginary axis. Okay? This one is the x-axis. That's what we call it now the real axis. Right? So if I've got z equal to a plus b in that, so now the conjugate of that will be on this side. Can you see the conjugate of that is a minus bi? So if I take a complex number and multiply it with its conjugate, I always get a real number. Here's an example. If I take 2 plus I and multiply it with 2 plus I, or 2 minus I, the answer will always be a real number. You'll get these questions in your assessments, that if I've got 2 times 2 there, it's 4. 2 times negative I, it's negative 2I. This times that will give me a positive 2I, and I times I will give me a negative I squared. So which means this 2 here will give me a 0. I'll get 4 minus I squared. What do I know about I squared? Negative 1. So I'll get 4 minus into negative 1. Now my answer will be 5. And 5 is a real number. See? So if I take a conjugate, so please practice. Go and take a lot of them. Then from there, just change the sign, multiply them together, and see if you can get a real number. So if I take a conjugate, multiply it with a complex number, then I'll get a real number. Right. Now let's look at the activity on conjugates. In this case here, I have, so this is a complex number, this is its conjugate. So you must check carefully in the assessment that is there a bar on top of the z that has been written. If there's a bar on top, then you must know, oh, it's a conjugate. And these examiners are very tricky. Sometimes they give you the conjugate. They want you to give them the complex number. So you must know. You just change the sign of the imaginary, nothing else. So here I'll have 2 plus 2i. Now, what is the conjugate of this one? Of z1. So the conjugate of z1 will be, I'm adding, remember, I'm adding its conjugate, then I have 2 minus 2i. See, I'm not using z2, I'm using z1 only. So here I'll have 2 plus 2i plus 2 minus 2i. That's an easy one to do. Remember, when you add and subtract, we add like terms together. So 2 plus 2 is 4. 2i minus 2i is 0. So my answer there will always be that. So what can we conclude here? That if I've got a number and I add it to its conjugate, the answer will always be a real number. But let's check with this one. Now with this one, we are having a conjugate of z1 and a conjugate of z2. So what am I doing here? I'm multiplying what? 2 minus 2i. I'm multiplying it with the conjugate of this one, which is negative 3 plus 3i. You see, because this is a minus 3i, need a conjugate to do plus 3i. So then I just multiply using the FOIL. 2 times negative 3 is negative 6. 2 times 3i is going to be 6i. Negative 2i times negative 3 will give me positive 6i. Negative 2i times 3i will give me negative 6i squared. Then I'm going to have negative 6 plus 12i minus 6 into negative 1. Remember, when you see I squared, just replace it by negative 1. Then I'm going to have a plus 6 here, and 6 plus 6 is 0. 6 minus 6 is 0. Then my answer there is going to be 12i. Because this one is going to be negative times negative is positive. Positive 6 minus 6 will give us a 0. Only 12i is left there. Okay. All right. Working with complex numbers. These are just some quick notes that I've just put in there. How do I add, subtract? We've already done some of them. How do we multiply, and how do we multiply complex numbers? So when we add complex numbers, remember when we add, the real part will add together and the other parts will add together. In this case, they just made it easy for us that this and this are the real parts are added together, and then from the this and this are the imaginary part, they are also added together. Same applies to subtraction. We'll do the same. With multiplication, we've already done one of them, that we multiply, and then from there, this imaginary parts will be added together. Then we have an I squared that we need to change to make it negative 1, and then from there we'll be able to can multiply. Can we take a 2 minutes break? Then we'll be back. Okay, welcome back. All right, the this is also very important, and these are questions that are also set in an assessment to say, please represent a given complex number on an Argand diagram. So the Argand diagram is the diagram that we already talked about. That is the diagram where we have the imaginary and we have the real part. So when I want to put a number, a coordinate on an Argand diagram or a complex number on an Argand diagram, this is what I should know. That the imaginary axis is this one. Then we have got the real axis here. So that's what we need to know. If you check here, I've already put some numbers in there. 2 plus 3i. So if I want to put 2 plus 3i, what do they do here? 2 is the real part, 3i is the imaginary part. So from there, I first go to the real part, the real axis, and locate my 2. And then go into my imaginary part here, and I locate a 3. Then from there, I can be able to have a 2 and a 3. That's where they meet, and that is our resultant. Right, so we have a real part and an imaginary part. So in this one, you are given 3 as the real part and 2i as an imaginary part. So first I must locate the negative 3. So it's negative 3 as the real value and 2 as my imaginary. So that's where the 2 meet, and that's my resultant. Right. If you check this one here, what can you tell me? We've already done that. If you see there's a plus 2i here and there's a minus 2i here, what is the correct terminology that we use there? They are conjugates. So which means I've got a negative 3 here and a negative 2. So that's where they meet. Right. That's where they meet. And obviously, if I add this one and that one here, what will happen? Let's check. If I take minus 3 plus 2i, and then I'm adding it to negative 3 minus 2i. So I'll have negative 3 plus 2i minus 3 minus 2i. And my answer, obviously, that and that will fall off. My answer there will be negative 6. Can I calculate it on the sketch? Yes, because I know from here, there, from there to there, it's negative 2, and from there to there, it's negative 2. So I can be able to calculate that length. Not the length here, but the resultant of this one. The addition, if I add this one and that one, then I get negative 6, the resultant of that. Okay, so now you can be able to add them on the sketch. We are also be able to subtract that, and we are able to multiply that, and I've shown you how we can do that. So when we say represent this on the sketch, this is what you are supposed to do. So I can add those two. When I add this, then the answer there becomes negative 6. Right, if I subtract this, you can do that also. If I multiply this, remember when I multiply them, the two conjugates, the complex number and its conjugate, when I multiply them, then I get a real part also. Okay, when I add them, I also get a real part. Now, complex numbers, this can be plotted on a 2-dimensional plane where A is plotted on the x-axis and B is plotted on the y-axis. The x-axis is the real part and the y-axis is the imaginary part. So you must be able to put any number. If, for instance, they say put 3i. So I know that 3i is the same as 0 plus 3i, which means that on my real part it will be 0, on my imaginary part, it must be 3, so it will be there. So my point will be there on the 3. Okay. If I'm requested to put -2, then I know I just go and put it there. Okay, on an Argand diagram. Right. Now, still on the Argand diagram where we have the imaginary and the real part. The A here is the real part. The B here is the imaginary part. The complex number is A plus BI. This is the point there. Now, if you look at this, we have a right-angled triangle. In a right-angled triangle, they've just included the angle theta there. So in a right-angled triangle, we can be able to get the value of R, which is the hypotenuse. It is called a radius when we have a circle. Right, so if I've got a unit circle here, then I'll call it a radius. So in this case, it's a hypotenuse because I'm talking to a right-angled triangle. So now, this hypotenuse that we're talking about here, in complex numbers, we call it a modulus. So in other words, a modulus is nothing else but a hypotenuse in a right-angled triangle. Right? Now I'm having a line here and a line there, and there's an amount of space in there, and that amount of space is an angle, and that angle is formed by the radius, by the hypotenuse and the x-axis in this case. So it is an angle between the x-axis and that line there, that red line. So that angle there, we call it an argument. So an argument is nothing else but the angle between that hypotenuse and the x-axis. Please, it cannot be there. So that angle there, it must be between the x-axis. Removing those angles from the x-axis and the line, which will be our hypotenuse in that case. All right, so that's an argument. So now we have discussed what is a conjugate, what is a complex number, what is a modulus, and what is an argument, and what is it, which one is the imaginary axis, which one is the real part. Know those concepts, because when you do your complex numbers, these are the terminology that is going to be used there. So please do not be caught napping in that instance. Now let's talk modulus and argument. So obviously we already know now that this thing modulus, it's nothing else but the hypotenuse. Then what is the argument there? We know it's nothing else but the angle. All right. So when you're practicing and all doing that, and then you must just know to those two terminologies, because sometimes they become a challenge. You know what to do, but because of the terminology that is used in that topic, you then have a challenge in terms of getting the answer. Now, as I said, the modulus is the hypotenuse, and we know that when we do hypotenuse, it's r squared equals to x squared plus y squared, right? But when we are talking this, when we are talking complex numbers as they are written as a plus bi, we're now going to say our modulus, which is r squared, is going to be a squared plus b squared. All right? So which translate to r equals to the square root of a squared plus b squared. And that is the talking about here. Why the plus sign? Remember, in this case, our radius, the answer that we must get must always be a positive sign. Okay, right. So if I've got a complex number given as z equals to a plus bi, therefore I know that my r will be equals to a squared plus b squared with a square root, and it's a plus sign. You don't need to write the plus sign, okay? All right. Now, what about the argument? Now, in terms of the argument, if the angle is in the first quadrant, remember with the argument, how do I get the angle, that angle that is formed by 2? Remember, let me draw the sketch. If I've got an angle that is formed there, remember the angle that is formed there, and I've got the B and I've got the A, which ratio must I use for this? If I've got the R, it's fine, I can use all the 3 ratios. But if I don't have an R, which ratio must I use? I must use the tangent, because the tangent is opposite over hypotenuse. Remember the TOA, opposite over adjacent, sorry. So that's why we use B over A. So we use the tangent. So in the first quadrant, I use it as it is. In grade 11, you have done trigonometry and the reduction formula, where you have 180 degrees, you have 360 degrees. In this quadrant, we use 180 minus. In this quadrant, we use 180 plus. In this quadrant, we use 360 minus. So this quadrant 2, quadrant 3, and quadrant 4. So this is what is explained here. I'm going to explain also here. In the first quadrant, no reduction formula. In the second quadrant, so why do we say in the second quadrant? Because if I've got my complex number as minus 2 maybe and 1, so it will be somewhere there, or minus 2 and 3, so it will be somewhere there. So in other words, if I draw my resultant here, so there I'll have a minus 3, a 3 plus 3, and there I'll have a minus 2. So in this case here, my angle comes from this side. So remember, we calculate the angle from that x-axis. So my angle will be this one here, right? So which means that it is more than 90 degrees but less than 180. So that's why we use 180 minus. So if my complex number is somewhere there, then I'll use 180 plus. If my complex number is somewhere there, then I'll use 360 minus. So that's what we do. So when you do the activities, then I'll show you what I'm talking about here. Right. Okay, so now we are now going to look at the activities that talks to the modulus and also talks to the argument. So the issue of argument and modulus, here's an activity that talks to that. Determine the modulus and the argument of the following. Now we are given z equals to -2 plus 3i. I'll always say to you, my boys and girls, that please make sure you draw the sketch first. You draw the Cartesian plane and indicate where this is, so that then when you do your argument, you are able to then check which quadrant will that be. All right, it's easy to do it like that. Then I'll know. So for instance, in this one, I think I've already done that. -2 is there, 3 is there, then from there, here is my point in there, then I'll draw my Cartesian plane, then from there I know the angle. But first, let's get the r. So my r is going to be the square root of my a is -2 squared plus b is 3. Please do not take the I, ne? Leave the I, because I know it's, the 3 is associated with the I. Then I'll have 4 plus 9 square root, and the answer is square root of 13. So that's my r. How do I get the angle? I know the angle will be in the second quadrant. So to get my argument, they will be equals to, I'll then say theta is equals to 180 degrees minus tangent of 3 over negative 2. Remember, it must be B over A. It must not be A over B. That's the mistake that we've always find this when we are marking the exam scripts. It must be B over A. Then this is minus 1 there. It is an inverse of that. So I'm going to go to my calculator and calculate it correctly now. So what I'll say 180 minus, now listen carefully. You say 180 minus the inverse, shift, tan, please do it with me. Then you put 3 over 2. You don't put negative 3 over 2. So because you need a reference angle. So you ignore that negative. Then you're going to say 3 over 2. And I hope my boys and girls, you also have your calculators. Then the answer that you're going to get there is 123.69 degrees. Can you see that that angle looks right? Because it is in the second quadrant. Because if you don't do it like this, then you get an angle in the first quadrant and you're thinking you're right, and that answer will not be correct. Okay, right. I'm also going to show you how we do that on a calculator. Right. The second one basically is the same thing. We are now going to say, how do I get the R? So the R is going to be the 12 squared plus 5 squared, right, sorry, 5 squared, 12 squared, negative 5 squared. Then the R there, it will be equals to 169, square root of 169, and the answer will be 13. Because 12 squared it's 144, 5 squared is 25, and then there's 169, square root of 169 is 13. So the R is 13. Now how do I get the angle? So same principle. If I draw my Cartesian plane here, where do I get this? The 12 is positive, the 5 is negative. Where they meet, it's my point. Here, this is where we have the angle is in the fourth quadrant. How do I get the angle in the fourth quadrant? 360 degrees minus the tangent, inverse tan of minus 5 over 12. Right? Remember, I don't use the negative inside the bracket. Then the answer that I'm going to get there is 337.38 degrees. Right? So those are the two questions on there. So this is how it is going to be asked. Then we're going to also show you how we do it on the calculator. Then we have the third one, which is Z, it's equals to -2. In this case now, we do not have an imaginary part. So which means when we draw our sketch, we're going to have a problem, imaginary and real part. So which means that my -2 will be there, but my imaginary is at 0, so this is what we're going to have, right? Which means now, if I need my R is going to be, so remember this one is going to be like this, because we don't have that 0, that I. So I'm going to say -2 squared plus 0 squared inside the square root. Then I'll have the square root of 4, and the square root of 4 is 2. So meaning that my R is 2, but now how am I going to get my modulus? My argument, sorry. So in terms of the argument, if I say tangent, so here it's in the second quadrant. So if I say my theta is going to be 180 degrees minus the tan of, then I'll have a 0 over -2, right? So this is going to be 0, obviously. So I'm going to get theta equals to the tan of 0. You go to your calculator. So the inverse of tan. All right, in this case. So if I go to my calculator and now go and say shift tan 0, and the answer is going to give me a 0. So in other words, I'm going to have 180 degrees minus a 0. Then from there, my answer will be 180 degrees, right? So if I take my angle here from the x-axis here up to there, I know this is 180. Now I know I got it. Okay, right. We are going to take a minute break, then we'll be back. Okay, now welcome back. Now the next part will be the polar form. So can you see? So we started with defining the complex number, then we did the addition and the subtraction, or just before we did that we also talked to the negative inside the square root, and also the I squared, it's equals to -1. And then now we talked also about the Argand diagram, which is a question in the exam. Then we now talked to the modulus and talk to the argument, which are also questions in the exam. Then now we're talking polar form. Now polar form means we need to write down, remember what we've been doing always, it was in rectangular form. So the one that we're writing, that one is in a rectangular form. So sometimes you might ask to write it in rectangular form from the polar, and sometimes from the polar, from the rectangular to polar. So this is just how the polar form was developed. All right. You don't need to know, they're not going to be asked in the exam, how do we get this? You just need to know it. But Sometimes it is good that you know exactly how it came about. Now, if for instance I take A, remember in a Cartesian plane, if I've got this one is A and that one is B and this one is theta and R. So if I need the sine of theta, the sine of theta will be B over R, which is that. So I'm talking about the A and the B. So the sine of theta is B over R. If I make B the subject of the formula, I can cross multiply there. The B will be equals to R sine theta. So the R will multiply there. So it will be R sine theta. So in the place of B, if I want to write it in a polar or trigonometric form, then the B must be replaced by R sine theta, which is this one. So the I is still there. Can you see that? So this thing here is nothing else but B from that. So if I take the cos will be A over R. A over R. Make A the subject of the formula, you get R cos theta. So that A here is represented by R cos theta. Can you see? And that's your polar form. So polar form means it must be written in the trigonometric form, which is R cos theta and R sin theta I. But I can see we've got a common factor here. We take it out. Then we have R into cos theta plus I sin theta. So if they say write it in polar form, it means that we need to get the value of R. We need to get the value of theta. And what is R and theta? We've done it before. We've done it 2 slides ago. It is the argument and the modulus. It's the modulus and the argument. So R is your modulus, theta is your argument. So if I've got the theta and the R, I'm able to write it in trig form. I cannot be able to do it if I don't have the R and the theta. Okay. These are the other forms that we're going to use. Sometimes you'll be asked to write it in these two forms. You must also know them. Ne? R is theta, so in other words, you need the R and the angle. Even here, you need the R and the angle. So all those three are polar forms. So I can write it in any form in there. All right. Calculator work. Now, I know you're having your calculators with me. Please, you must do it with me. And I want you to do this question by using a calculator. So if I've got a Z equals to 12 minus 5, I know we've already done it. We've already done this question. So it is from the rectangular. This is rectangular and we're taking it to polar form. So what you need to do on a calculator, and this calculator is a Casio calculator for you. Okay, the Casio calculator. So from the Casio calculator, you put in the value of A, which is going to be 12. Then you look for this button XY, which is a coordinate. XY, it's a coordinate. So look for that button. Then from there you put the value of B, which is minus 5. Then from there you press second function. After second function, you press the button 8. That's where you're going to get R theta. So in other words, I need the value of R and I also need the value of theta. So now you no longer need to do your Pythagoras theorem and then from there the tan, shift, what, and all that. The calculator gives you correct answers. Then you shift that. Then from there you press that button. The button, what appears on your screen is the R value, which is 13, and is your theta value, which is going to be 337.38 degrees. Lovely. So if you follow these steps here, you are going to get full marks. So you, in the exam, you just write down, if they ask you what is the value of R, you just write down R is 13. What is the value of theta? You write 337.38, then you work it out on your calculator. Okay. Sometimes they want you to change from polar to rectangular form. So same applies there. So in other words, they want you to change this to that. So obviously we're going to put a value of R, which is 13 in this case. Then from there you press that button XY coordinate. Then you put in the value of theta, which is 337.38. Then you press second function. In this case now you press 9. Then you're going to get the value of A and the value of B, which is 12 and minus 5. Sometimes you'll get decimals like 4.9 and the other one will be 11.9 or so, but it will be very close of what you have. You can just run that answer off. Okay. That is on a Sharp calculator. I mean on a Casio calculator. Right. The first one was on the Sharp calculator, and then we have the one on the Casio calculator also. Right. Now I'm going to use the old way without using a calculator. I don't know if there will be a question which says do not use a calculator to get R and theta. But yeah, so in terms of the calculators, your teachers can also be able to assist you in class in terms of the calculator, how to use a calculator to get the value of R and the value of theta and the other way around. In this case, the Z is equals to minus 2 plus 3i. Write down the following in polar form. So remember, polar form is the same as the trig form, the trigonometric form. What is the first thing that I need to do is to get the value of R. That is the first thing that I must do. First I must get the value of R. So the value of R is going to be negative 2 squared plus 3 squared inside the square root, and that will be 4 plus 9, which is 13, and that will be the square root of 13. Now how am I going to get the angle now? So the angle theta is the same. This question is the same as the one that we have done before. Then the angle was 123.69 degrees. Now how am I going to write this in polar form? So remember, in polar form, remember it's still a complex number, but in polar form. So first I must write down the R, then I write the cos of an angle, then plus I multiply by the sine of an angle. That is a polar form. Then my R here is square root of 13, open bracket, cos of an angle, plus I sine of the same angle. So this is in polar form. Or I can write it as R is square root of 13, then I write cis 123.69. Right? Okay, so this is how we write this in polar form. So polar form means that you must get the value of R and the value of theta. I can't get the polar form if I don't have R or I don't have a theta. Alternatively, we can use a calculator to get the value of R and the value of theta, put them in polar form, and that's what you do. Similarly, the same thing that we're going to do the same way. This one, so I know first I'm going to get, first in this one, because this one we haven't done yet, but first you can see the value of that one is minus 1, then we have got minus 0.5, so we have that, so I can just connect it here, then you can see the angle comes from the side. So we have got a negative 1 here, then we have got a negative 0,5. So we need to get the value of r first. So the value of r, I'm going to do it here. The value of r is going to be the square root of minus 1 squared plus a half squared, negative. So that answer that I'm going to get there will be 1 squared is 1, negative 1 squared is 1, 1 plus 1 over 4. So we must just check that one, 1 plus 1 over 4. So remember, this is going to be 1 plus 1 over 4. So the answer that I'm going to get there, it will be 4 plus 1 will be 5. So I'm going to get square root of 5 over 4. So 4 times 1 is 4, plus 1 is 5 over 4. So I'll get r is equals to 5 over square root of that. Ne? So now I've got my r, which is square root of 5 over 4. Then I need my theta, which is going to be, so in this case, I know it's in the third quadrant. So it's going to be 180 plus the tangent of, so it will be negative 0,5 over negative 1. Remember, it must be b over a. It must always be like that. But check, for instance, if the order of the complex number it's correct. So in this case, I'm going to get my theta there. If I work that one out, I think I've got 206,57. Then I can write it in polar form. So sorry, it's a z in polar form. So it will be square root of 5 over 4, open bracket, and then cos of 206.6. I'll just round this off, and then plus I, the sine of 206.6, and that is in polar form. Okay, if they don't ask it in which form, you can still write the easy version of square root of 13, so square root of 5 over 4 is 206.6 degrees. Right, so I can still write it on. Or if I don't want it in that form, I can write z equals to square root of 5 over 4, put this sign here of an angle to this. So those are the three forms. But sometimes they might say they want it in this form, they want it in that form, or they want it in that form. So please check your questions. And right, the last part of complex numbers is where we solve, which is 5 marks. This question comes almost every year. It's 5 marks, between 4 and 6 marks actually. So please make sure that we get this right. Now, if you're solving two variables, the complex equations with two variables, if two complex numbers are equal, which means that the modulus and argument will also be equal, right? Their respective real parts, so their real parts will also be equal, right? And the coefficients of, remember they're talking coefficients, they're not talking the imaginary parts. They say coefficients of the imaginary parts are also equal. So we are only going to concentrate on the coefficient. Must know what a coefficient is. If I've got 2a, 2 is a coefficient of a. Right. Now, therefore the real parts will be equal and the imaginary parts will also be equal. So we're only going to equate the real parts and the imaginary parts. Real parts together, imaginary parts together. So if I've got something like this, if I've got just 2 plus 3i equals to x plus yi, for instance. So in this case, I can see that for me to have the left-hand side to be equal to the right-hand side, the x must be 2 and the y must be 3. But how do I then get it? I'll then say the real parts together, like we have done there, and the imaginary parts together. So 2 is equals to x, and 3 will be equals to y. Can you see? So if x is 2 and y is 3, then the left hand side and the right hand side will be equal. Okay, so the real parts together, the imaginary parts together. Check this first question. 4 plus 3i equals to minus 2x minus y. Doesn't matter the order there. It's yi, doesn't matter. So, easy way to do it, pay attention, easy way to do it is to say the 4 is a real part. Which other thing there is a real part? This is a real part also. Anything that does not have I is a real part. This one is an imaginary, this one is imaginary. So anything that is real will be equated. Here's my equal sign. So I'm going to say 4, no real part here, it's equals to negative 2x. And the real part this side is 3, and the imaginary part this side is 3, and the imaginary part that side is negative y. Can you see? That's negative y. Please ignore the I. In this case, I can then solve for x on both sides. So I can say x in this side is going to be 4 divided by negative 2, which is negative 2. Right? This case, I must just divide by negative 1. So, and the y will be equals to negative 3. So these are my answers. So the x value will be negative 2, and the y value there is going to be the y value there is going to be negative 3. So if I come here and put this one as negative 3, and then I put the x value as negative 2, that right hand side and the left hand side will be equal. You can check it on your own there. Same applies to this one. In this case, I can see I don't have any real part, so I can just like, okay, let me just being naughty here. Let's put a 0 there, plus 0. Now, which one is the real? This is the real part. This is the real part. This is the imaginary, and real. Right? So let's put that together. The real part plus the real part. Any real part on the left? Nothing. On the right hand side, the real part is 0. Then let's solve for x here. Can you solve for x? We have got 2 variables. Bad. I can't solve for x when I have these 2 variables. I must make a plan with the imaginary. With the imaginary, I've got x on the left for imaginary. Remember, ignore them. Then on the other side, I've got a 4, which is the imaginary. Right? So x equals to 4. Lovely. What do I have now? Substitute this x here, there, to get the value of y. So I'm going to say 2 into 4 plus 2y equals to 0. Then I'll have 2y equals to negative 8. Transpose that. Then y will be equals to negative 4. So I've got the value of x, which is 4, and the value of y, which is negative 4. Those are the 2 values. Remember, we're solving for x and y. Okay, right. Now the third one, in the next slide, the fourth one, first of all, I must, or I don't need to multiply out the brackets. because the 4x plus 1 is an imaginary, the whole thing there is an imaginary number. So my real part here, I don't have any real part here, so I'm going to just add a 0, right? So first, this is real, this is imaginary, this is imaginary, and this is real. So I can just add a 0 there to make a 0i there to make an imaginary, okay? Right, so I can have the real part is y equals to 0 because there's a 0 there. And my imaginary is going to be a 0 on my left hand side. There's now imaginary value there. Then I'm going to say it's 4x plus 1 minus a 3 because I'm ignoring the I, remember. So I'm going to say 4x plus 1 minus 3. Then I can solve for x here. The y we already have an answer. Then the y, the x value, if I add this, then I get 4x minus 2 equals to 0. Then I've got 4x equals to 2. And then the x will be 2 over 4, which is 1 over 2. Right, and this is the x value and the y value. See, I did not multiply the I because then I end up confusing everything. I just need the whole thing there to be I. Right, the last question that we're going to do for the day, it's a bit tricky. It's a bit tricky because of the division there. And 2 plus I, you know, there's a real part and an imaginary part. So this thing here, it's a bit tricky for me. Right, so then we must make a plan. But I know when I divide complex numbers, 2 plus I, 2 minus I. So now, if I divide complex numbers, I must first multiply this by its conjugate. So for me, I take the denominator, which is 2 minus I. What is the conjugate for 2 minus I? It will be 2 plus I. And I also divide by 2 plus I. So that it looks like I'm multiplying this whole thing there by something different. But no, I'm just multiplying by 1. But I just want to eliminate that denominator as a complex number. So I want it to be real. So remember, when I multiply a conjugate by a complex number, I get real value. So this is what I want to do. So on top there, I'm going to get 4, multiplying this and that, I'm going to get 4 plus 4i plus I squared. At the bottom, I'm going to get 4 minus I squared. Remember, it's the difference of 2 squares, eh? Right? So I'm going to get 4 plus 4i plus I squared. So now, here, what am I going to do? The I squared is negative 1. So it's going to be 4 minus 1. So which is going to be a 3 plus 4i. At the bottom there, the I squared is minus 1. 4 minus into minus 1 will give us a 5. So in other words, this is minus 1. Minus times minus is positive. 4 plus 1 will give us a 5. If it's written like this, I now need to break it down. Remember, we have done this earlier. It will be 3 over 5 plus 4 over 5i. This is in the form a plus bi. Okay, so already I've done this part. Now I can rewrite this and say x minus yi equals to I minus 4 plus, I write it like this now, 3 over 5 plus 4 over 5i. Then I can do my majiki. So my majiki, this is real, this is imaginary, this is imaginary, this is real, this is real, and this is imaginary. imaginaries together, real together. So on my left hand side, I have an x as real. Any real now here? Nothing. So on the right hand side, I've got my real, which is -4, my real, which is 3/5. I'm done with my real part. Now on the imaginary, I have -y equals 2. This is 1, remember? It's 1. The other one is +4/5. Don't put an I, please. So this is done. That is also done. So now I can then work this one out. 5 times 4, it's 20. -20 plus 3 is -17/5. With the y value here, remember there's a negative here, so my y will be equals to 5 times 1 is 5 plus 4 is 9, and 9, so it will be -9/5. Okay, because of that 1 there, because of the -y that we had there, so it's -y. Is it -y? Yes, it's -y. So because of the -y, we are able to get the values of x and y. So remember, first I can do that on the side, so that then I don't want the complex numbers. I don't want complex numbers as a denominator. So what I need to do, every time I get this, then I use the conjugate, I multiply it by its conjugate, right? Then I multiply it by its conjugate and divide it also by the same conjugate, so that then it looks like I'm multiplying by 1. Okay, then I get the value of x, get the value of y, and once I get the value of x and the value of y, I'm able to get full marks in there. Let me take this opportunity to thank you for watching, and please keep practicing this topic. It's a very, very, very easy topic. We can all get 15 marks and we'll be in the right direction to get full marks in paper 1. Thank you so much.